Hello, and welcome to section 1.1 in our intermediate algebra course. So for those that had me for elementary algebra, you're going to see a little bit of the same stuff. So, the first chapter is going to be review for you. And for those that have me for the first time, welcome. And let's just get into it here. So, so section 1.1 talks about a lot of things. So we're going to go over factoring, least common multiples, order of operation, what it means to evaluate expression, combining like terms, and then translating English to algebra. So a lot of it will probably be review actually, because this is stuff that we've seen a long time ago. But if it's been a while for you, that's okay. That's just how, re-entering the world of math is. Okay, so first of all, let's talk about factors and multiples. Okay, so let's say, for instance, you have, the number 2. The multiples of 2 are basically counting in groups of 2. So then the multiples of 2 would be 2, 4, 6, 8, 10, 12, 14, and so on. Basically the even numbers, right? Which makes sense. Because it's 2 multiplied 3 times, and then here, let's say, for instance, you have multiples of 3, counting by 3s, 3, 6, 9, 12, 15, 18. So that's the multiples of a number, basically, right? Here's some, here's some pretty common multiples. You have 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just good to understand what they look like. If you haven't seen it in a while. Okay, so it's basically a product is a number is a multiple of a different number if you can write it as a product of a counting number and n. So let's say, for instance, 15 is a multiple of 3 because 3 times 5 is 15, Another way that you can talk about multiples is say that the product is divisible by one number. Okay, so let's say to say something is divisible by another thing means that if you divide it, you get a whole number, right? A counting number. So let's say, for instance, we said before that 3 times 5 is 15. Sorry about that. We said 3 times 5 is 15. And so 15 divided by 3 is 5 as well. Okay, so that's one thing. So if a number is a multiple of n, of a number m is a multiple of n, then m is divisible by n. So since 15 is a multiple of 3, then 15 is divisible by 3. That makes sense, right? You can divide by it. All right, so the interesting thing about understanding multiples and divisibility is because we can come up with these divisibility tests. Okay, so if you have a number and you want to know, well, what's it divisible by? It's really helpful to know that, especially when you're factoring. Okay, because that's essentially what we're doing. So let's look at these rules here. So if you have a number that's even, right? Like it ends with 0, 2, 4, 6, and 8. Basically, that number can be divided in half, okay? You can divide that by 2. If you have a number that's such that the sum of the digits is divisible by 3, then the number itself will also be divisible by 3. So for example, 18, the sum of the digits is 1 plus 8, which is 9. 9 is divisible by 3. It becomes 3 itself. So 18 is also divisible by 3, which it is. It's 6. Okay. A number is divisible by 5 if the last digit is 5 or 0. An example of this would be 25, right? 25 divided by 5 is 5 itself. And if it's divisible by both 2 and 3, again 18, right? It's divisible. 18 divided by 2 is 9. 18 divided by 3 is 6. So 18 is divisible by 6. And in fact, it is. The answer to that is 3. And if the number ends with 0, it's divisible by 10, because you can count by tens, right? 40 is 4 times 10, 50 is 5 times 10, and so on. Okay, so let's do an example here. Is 5,625 divisible by 2? So right away, you notice the last digit here is a 5. It's not 0, not 2, not 4, not 6, not 8. It's not even, so no. No, not divisible by 2. Not by 2. It's not divisible by 2. How about 3? Let's add the digits together and see what we get. So you have here 11 plus 3, plus 2, which is 13, plus 5 is 18. That's divisible by 3. So yes, 5,625 is divisible by 3. Okay, and then is the last digit 5 or 0? It is. So yes, divisible by 5. Divisible by 5. Okay, and it's not divisible by 2 and 3, so it's not divisible by 6, so no to 6. And does it end with 0? No, so it's not. So the only ones that it is divisible by is 3 and 5. Okay, all right, let's see here. So when you have something that is divisible by another number, the number that you're dividing into is also known as a factor. So let's say, for instance, 72 is a multiple of 8. 72 is divisible by 8, meaning you can divide it by 8 evenly. And 72 is a multiple of 9 also, so it's divisible by 9. And we can rewrite 72 as the product of 8 and 9. Okay, so these are factors. When you can rewrite a number in terms of at least 2 or more other numbers being multiplied, those are factors. Okay, so there's a lot of ways to factor 72. 1 times 72, 2 times 36, 3 times 24, 4 times 18, and 6 times 12. So all of these numbers are factors of 72. Not all at the same time, but they're all potential factors. Okay, right. So if you have a number that's a product of 2 others, then A and B are considered factors. Okay, then let's get into primes and composites. So prime numbers are basically a number that's greater than 1, which only has the factors 1 and itself. It's not divisible by anything else other than itself and 1. And a composite, so example of primes, right, would be 3, 5, 7, 11, right, 13. Those do not have any factors other than itself and 1. Now, composite number is a counting number that's not prime, basically. So, example 6, 4, 10, 12, and so on. Some people might say, well, all are composites all even numbers? No, because 15 is not prime. 15 is a composite, right? It's the product of 2 primes. But prime numbers, all prime numbers are prime. Are odd, because what is an even number that's not divisible by 2? There isn't one. So, I guess the only one that I could think of other than, all the prime numbers are odd except for 2 itself, because 2 is the only number that is even, that is divisible by itself and 1. Okay, so here we have a little chart where you have the number, the factors, and is it prime or composite. So notice that all the numbers that just have itself and 1 as factors are prime, right? Prime, 5 is prime, 2, 3 are prime, 7 is 1 times 7 prime. The rest are composite. 11, just like I said, 13, and then we have 17 and 19. Okay, those are the first few primes. And the only even prime is 2. Other than that, it's odd. Okay, so every composite number can be rewritten as a unique product of primes. That means that there's one way to break it all apart where it consists of only primes, and that's what you call the prime factorization of that number. Okay, so that's helpful. Here, let's see what this is here. So let's talk a little bit about prime factorization. Prime factorization of a composite number is when you take that number and you break it apart into what we call you can use what's called a factor tree. I like the factor tree. It's nice. It's easily understood. So let's go ahead and do that. So prime factorization of 252. So we can divide. So the way that we do it, we create branches. So let's say we have 252 and we want to split this up. So I already noticed that 252 is even. So I can divide that by 2. I can also divide it by 3 because 2 plus 5 plus 2 is divisible by 3, right? 9 is divisible by 3. So I can also divide it by 6. So let's say I did that. So what's 252 divided by 6? So the 252 is 6 times 42, right? These two multiplied together give me 252. And the factors of 6 that are primes are 2 and 3. So once you get to the edge of the branch, you circle it. So what's the factors of 42? Let's pick any one. We could do 2 and 21. That's fine. That's prime, so I circle it. What are the factors of 21? 3 and 7. Okay, so that's basically it. So the prime factorization of 252 is 2 times 2 times 3 times 3 times 7. Okay, so basically I've taken this number and I've split it up into primes. Okay, I've factored it into primes. Okay, so let's continue. Let's do another one. So 48, 6 times 8. 6 factors into 2 times 3, and that's the primes. 8 is 2 times 4, and then 4 is 2 times 2. Okay, so 48 is, 2 times itself 4 times, and then 3. How about 80? So 80 is 8 times 10. 8 is 2 times 4. 4 is 2 times 2. We circle the primes. 10 is 2 times 5, and that's it. So the factorization of 80 is 2 times 2 times 2 times 2 times 5. Okay, not too bad. All right, so let's talk about the next thing. So it brings us into, now we're ready to talk about least common multiples. So the least common multiple of two numbers is the smallest number that is a multiple of both of the numbers. So let's say, for instance, you have 2 and you have 3, okay? What are the multiples of 2? 2, 4, 6, 8, 10, and da-da-da. And then the multiples of 3, you have 3 itself, 6, 9, 12, 15, and so on. Which is the least possible number that they have in common? So 6 is a multiple of 3 and 6 is a multiple of 2. So the least common multiple for 2 and 3 is 6. Okay, that's the smallest number that appears in both lists. Oops. Okay, so let's see. Let's do an instance of 12 and 18. Okay, so 12, we have the multiples, sorry, not factors, multiples. 12, 24, 36, 48, 60, 72, 84, 96, 108. And if I list the multiples of 18, I get 18, 36, 54, 72, 90, and 108. The ones that are in common are 36, 72, and 108, but the least one is here, 36, okay? That's the least common multiple, okay? So a number can have more than one common multiple, but the least possible is, what we're interested in. Okay, so let's see here. Let's do some super fun examples. Let's find the least common multiple of 15 and 20 by listing multiples. Okay, fine. So we have 15. We start with 15. Then 15 plus 15, that's 30, right? Times 2. 15 times 3, 45. 15 times 4, 60. Then the next is 75. And then you have 90. Okay, let's do 20. 20, and so on, right? It could keep going. 20, 40, right? 60, 80. And then wait a second, I can stop there because I noticed that I have 60 in common. So the LCM, or the least common multiple of 15 and 20, is 60. Okay, let's do 9 and 12. 9 and 12 by listing multiples. You have 9, 18, 27, 36, 45, 54, and so on. 12, you have 24, 12, 24, 36, 48, but then I can stop there because I notice that 36 is in common. So the LCM for these two is 36. Okay. All right. Now that's all very well and good, but what if you have a large number that you're trying to find the LCM of, right? It doesn't seem very, let's say you're trying to find the LCM of like, I don't know, 1,027, and then you also are trying to find, if they have anything in common with 17. So you're going to be, listing quite a bit of numbers, right? So you don't really, it's not super practical to be always listing numbers to find the LCM, okay? So luckily for us, there's another way. And another way is using the prime factors method. Now, the book has you writing it into columns, but what I like to do is to use, the factorization tree, the prime factorization tree, and then go ahead and list, the multiples. And I'll show you what this is. So let's say we want to find the LCM of 24 and 36. So let's go ahead and do that. So we have 24 and 36. Now we're not going to list, we're going to do a prime factorization tree. So that's 3 times 8. I'm circling it because it's prime, and that's 2 times 4, and 4 is 2 times 2. Okay, now 36, that's 3 times 12. 12 is 3 times 4, and 4 is 2 times 2. Okay, so when we write out our LCM, we're going to write it as a list of primes. So our LCM, okay, so the way that we do this is we take out each pair of primes and write it down in our LCM. So I'll show you what that means. So here we have a pair of 3s. Okay, that's 3 right here. When we have a pair of 2s, there we go, 2. Another pair of 2s. Okay, that's another 2. Now, whatever's left over, we just include that into the LCM. So times 2 times 3. So if I was to multiply all this out, I get, 6 times 2, 12, 24 times 3, which is 72. So the LCM is 72. Now, the way that the book does it, they have you write it down as a list. And then, so I'll show you really quickly how the book does it. So the book will go, okay, 24, you can rewrite that as 2 times 2 times 2 times 3. That's a 2. And then 36, you have 2 times 2 times 3 times 3. So then your LCM is going to be, so it's a little tricky because you have to make sure you line them up, right? So either way, in any case, you just bring down 2. These are together, so that's a 2. These are together, that's another 2. These are together, that's a 3. And that's finally the same answer. So you'll still get 72. So that's the way the book does it, so you understand where the book comes from. But I think it's the same thing as canceling out pairs. It's the same idea. Okay, so let's go ahead and introduce a few more terms. We have variable and we have constant. Variable, an example is just letters, right? That represents numbers. Okay, now they may change, right? So that's why we use letters, because it just depends on the situation. Now, a constant is a number whose value always stays the same. Now, variables can be different numbers. They're variable. But a constant is like, let's say, for instance, just a number that the ones we know, 3, 5, 7, 287. Like 287 is going to be 287 no matter where you go. It's not going to change. It's not going to someday wake up and represent 1,000. It's going to be 287. So that's what a constant is. An easier way to think of a constant is, okay, if it's a number by itself with no letter attached to it, it's a constant. Okay, so from that, let's talk about 4 operations: addition, subtraction, multiplication, division. We know what that is, right? If we don't, here's what they are. That just means I want you to be familiar with the notation and the words. Okay, usually the words is what, So let's say here we have the operation addition. You take them and you add them together. And we can rewrite that as A plus B. And we could say the result is the sum of A plus B. Subtraction would be A minus B. And it's also written as the difference of A and B. So the difference, multiplication, A times B has all these ways of expressing multiplication, dot next to each other, parentheses, one in parentheses, the other in parentheses. And the answer is called the product, okay? Now division, we have we have this division symbol, we have a slash, we have a fraction, and we have the little house, right? Divided by B, A divided by B, and we call this the quotient. We call this the quotient, okay? Where A, and also A is the dividend, the first number is the dividend, and whatever you're dividing by, that's the divisor, okay? All right. So let's see what else. What else can I tell you? What's next? Here we have an equality. Oh, of course, we cannot forget equality, right? The equality is basically an equal sign, right? It's really important that, I know we take this stuff for granted. We go, oh yeah, of course, equal sign, duh, hello, I know what that is. And that's fine, but sometimes, like, you know, we need to be able to understand, this is a math class, we take symbols very seriously, okay? So let's say, for instance, if you say x equals 3, that just means that that variable x has that value of 3. So if you have, let's look at a number line, and we're going to introduce inequalities in just 1 second.